All right, so now you've heard from the top three placing teams here. I hope you've saved up your questions to ask them. Feel free to ask general questions, and we can have each one of them respond. Who would like to kick off the questions here? Hao, you've got to have a question, don't you?
Yeah. Thank you very much. Actually, this question is not related to all your work, but did you guys, because you guys all extensively use our graph, right? And also many of these participants here, do you have any suggestions, like how should we further improve the quality of a graph? Yeah. Or did you find any issues of our graph and some obvious noise? Yeah.
Can I? Okay. All right. I can start. We didn't attempt to curate the graph in any way, so we didn't look at missing information, or we didn't check we didn't validate the data at all. We just used what it was there. Would have been useful though to have a distinction between the type of papers present there. So if it's like journal or workshop or tutorial or poster, because that's I think that gives a better picture of what kind of how important, how do you sort of value that paper more, right?
I see.
In terms of the amount of work that went into it, and that could improve a lot of things like the ranking or search relevance or whatever product you base on top of it. That's kind of it. So for me.
So we want to try out, do some data mining on the abstract or something about some synopsis or something. So we did not find anything in the Microsoft Academic Graph. So if we had that data, we thought like we could do some more, we could get some more, extract some more information regarding the paper. So that was one thing.
And I would like to add one more thing. So the one difficulty that we faced is so the affiliation has got many representations. So for example, National University of Singapore can be represented as National University of Singapore, NUS, and some other form of misspelling or other representations. So if we have any means of actually resolving them into one particular thing, so that would be helpful.
Okay, great, thank you. So another question is we have a really rich citation information, right? So I think probably you guys don't have time to try out this idea. So have you looked into the citations? Why not just try using the paper cited, what kind of paper to aggregate the data to make the prediction?
So we actually we tried a lot of stuff. What you guys saw and what is in the paper is sort of the stuff that actually worked. We for instance looked at the papers at Wisdom Cup, and we actually computed like paper scores according to the same methods that the guys that won the cup used. We actually based on the citations, right? If that is what you mean. So we actually created features based on the number of citations that you guys had in the Microsoft Academic Graph. However, we didn't see an improvement actually. Maybe just for our method. Maybe in other methods it could have helped. For instance, I was curious. Also, as a side note, probably you use citations to compute the paper rank. There's like a field in the Academic Graph.
Yeah.
But how do you? So it's just like the ratio between in degree or out degree, or how did you do it actually?
Yeah, we have also learning methods to create the rank. Citation is just a part of the factor. Yeah.
Okay.
Thank you.
So on a related note, did all three of your team's approaches use the full downloaded Microsoft Academic Graph? Did any of you use the API, which is sort of rolling added content? So the work that our team is doing is consistently on a weekly basis adding new data into the graph, new citation edges, but also new author completions and new author name or author affiliation assignments. So what you were looking at was a snapshot in time of the data back in about February of this year, whereas sort of rolling forward, we've been adding more data. Did anybody here use the API for that? No. Okay. You would have found the abstracts in there, by the way, if you had. So but we're looking at other ways that we can enrich that data to provide more linguistic data sets in there to take advantage of exactly what you're looking for. So, other questions from anybody? Yes.
Curious to know what implementations of the models you used, the GBDT and other models.
Implementation of models, and we use 3 models, and first baseline model, it's very simple, so we implement it by ourselves, and the second is regression model. We use linear regression and support vector regression, and the tool we used is scikit-learn, and the third is rank SVM, and we use SVM rank by Cornell.
We used only R to do the modeling in, and basically everything else. We used XGBoost for the gradient boosted decision tree. Like, what else? For now. We used, so for the mixed effects, we used like an R package called LME4, I think it's called. And for instance, for the features, for the trend-based features, we used forecast package to get like drift trend and simple exponential smoothing where we estimated the smoothing parameter. Did we do any? No. Mihai? No. That's it.
So we did our modeling part in R. We used the packages like Random Forest, E1071, Neural Net. For linear regression, we use the base package. That's it.
Good. Other questions?
Sorry, I'm a bit late for top 1 team, but I have a question about the top 1, top 2 team. I think that you both use the related conferences as the features. So I want to know about I think there are 2 effects of the two sides of the effects of the related conference. If you submit to the World Wide Web conference, so then accept it. So I think if you have one research topics, so I think there is no possibility to get accepted to submit to the KDD conference. So, but in the top 2 team, you said that if you have acceptance ability in the past World Wide Conference, so you have a good possibility to get accepted in the next KDD conference, as he said. So, which from your are there any insights from the related conference? What kind of insights from assumptions or you used in these competitions? So are there any reasons or insights from?
Just so I'm sure I understand, you mean like related conferences?
Yeah, related conference. So
Okay.
I think there is some kind of effects from both good effects or bad effects.
Sure. So the way we tried to use the related conferences was just to kind of enlarge our data set, the one that we actually train our models on, because the boosted decision trees, the gradient boosted decision tree model, I mean, the more data you put into it, the better it's going to perform. That we saw that. So that was the reason behind it. We experimented with a lot of related conferences for all the conferences in the final phase. We actually didn't have that in phase 2. It was just something that we did in the last phase. And we basically tried to experiment with a lot of different numbers of related conferences, up to, I think, 20. But at some point, it was simply overfitting. So I think we stopped it with like 10. We found a balance there that was kind of outperforming, performing the best compared to our baseline. So we just stopped, like, we found the kind of the good balance for each of the conferences. Does that answer your question? Okay. So, and him as well?
We also add similar conference features in order to expand the feature set. Our intuition is that in phase 1, we look at the history results in SIGCOMM, but we found some some universities they publish zero papers in recent 5 years, but in recent 4 years from 2011 to 2014, but they have many papers in 2015. So we want to check what's the reason for that, and we found that they in the last 4 years they published papers in InfoComm and GlobeComm. So we assume that if we consider these similar conferences, then we can incorporate more useful information for measure its probability to publish papers in this conference.
Yeah, I have just something that I want to add is some of the conferences are more volatile in the sense of who's making it in the top 20 than others. So for us, I think our model, the model that we had in the phase 3 of the competition, I think would have performed very well in the phase 2. But somehow for I think the top 20 is a bit more volatile than in KDD's case. So it's definitely some more experimentation to do. It's not like one fit all kind of case. So you have to be careful with that.
Thank you very much. Did you use the World Wide Web 2000 this year's World Wide Web conference results? I think it's not in MH.
It was not in the graph that we published in February, but via the API, you would have been able to, probably within a few weeks of when that conference was, we had that before. But so you guys already said that you did not use the API, so.
No. But we did, however, use SIG IR and KDD results in 2016, which we kind of crawled ourselves once they were published from their website. And we used it as sort of an extra validation. But we didn't get the same results as they were on the private leaderboard so we didn't have access to the camera ready. And there were some mismatch in the names of the conferences, in the names of the affiliations, which I think we couldn't kind of match.
Got it. Okay.
Are there some methods that you tried and didn't really work out, though they may seem like good idea or straightforward ideas to begin with? Any of those that kind of surprise you or find interesting? Any methods or, I guess, idea that you explored?
No. I think I kind of expected the mixed models and linear models to kind of perform a bit better. So I think we didn't have enough. I mean, we didn't spend enough time on kind of playing with them so much. After phase 2, we saw that we had a good predictive model going on with the boosted decision trees, and basically what we tried in phase 3 was to not mess it up too much. I don't think we tried. Did we experiment, Mihai, with something else? I don't think so, right? Not really.
More time designing features rather than
trying different models.
Okay.
Yeah.
Since earlier you mentioned that you tried on the citation or reference relationship and it doesn't quite work out very well, I'm just curious if there are any other such kind of feature engineering you tried and it's not working as expected? Anything else? Maybe something like the citation, or I don't know. I'm just curious.
Yeah, so general
Yeah.
negative results are
Yeah, just sharing other things you may try but not quite work well?
So I think we took out actually the author impact factor based features in the last phase because they weren't doing very well. With the paper scores, yeah, we didn't use at all. In sort of the ones built on top of the citation network, we didn't use that at all. Other features, I think we also took out some of the features in like the weighted trends, the trends which we in the second phase we did some weighted trends looking back in the last years with weights we picked out manually basically, and we took those out. But I wouldn't say other very important things that we used and it didn't work. So we didn't experiment that much. I mean, we didn't invest so much time because we didn't have that.
I think we've tried. We tried to see the performance of different features and different models. But I think the performance there will be difference, but the difference is very small. I think in these conferences, a little improvement or a little decrease does not mean that the feature is not good or the model is not good. So all we want to do in the competition is that we define reasonable features and use reasonable models and try to give stable results. But I don't think if we make it the best in our in the experiment we do, but I don't think it will help us to have good performance in the competition. So we just try to use reasonable features and models.
The number of features which we have built was very less, so we could not try out more features. That was the one concern we have. But other than that, the reach score which we computed did not contribute much, which we thought we would have gone with a citation network rather than a collaboration network. So that was one thing we thought we could have, if we had time, we could have changed it from the collaboration network to the citation network and try to compute a reach score.
Yeah, I think one of the nice things for us in both hosting and then listening, reading all of the results from multiple teams trying to solve the same problem at the same time is you get this very large, over 500 teams focused on the same problem, and so you see both the commonalities, you see the common areas that a lot of teams try and are successful, and then you also see some of the tailed ideas that maybe panned out or didn't pan out. And so it's helpful for us to sort of listen to both sides of the equation from all of you. A related question is you heard Hao talk about at the beginning of the day, we set out with a different idea in mind, and we ended up having to change it sort of based on what we could build a challenge around where we would have some evaluation data. Did any of you have ideas through the course of this challenge of other challenges that you'd like to see done or other areas for research that you think would be a good application of this data set? Did any eureka moments of saying, hey, I wish the challenge was something else, or I wish there would be another challenge that would take advantage of something else, a different approach that you had taken? You can think about that for a little bit, and we'll.
It's a deeper question, right?
Yeah. But we really think that these challenges are ways that we can sort of rapidly accelerate some of these research activities in a common area by getting the community to focus on them at one time. And it's just for us trying to find the balance between something that is evaluatable, especially in a short period of time when we had a closed window for doing this. I think there's a question over here, Joe.
From your experience, how important is it to differentiate between full research papers and regular papers, and also the history of the data, as in only 5 years, would that be sufficient? Would it improve if we have more available data?
I think there is differences between full research papers and all papers. but we do not very carefully check the differences between these papers. I think maybe there are some universities, they do not publish full papers, but they publish something like poster papers. And in our method, we use we mainly use the 4 research papers, and we only use the recent 5 years research paper because that's what the dataset contains, and we do not use the data many years ago because they may be not very helpful to predict the acceptance in this year. But I think actually we do not do very carefully. We do not very carefully check the how many years is the best. Okay, so we used last 3 years to predict this year.
So I think using all the papers, it would be actually very interesting to see to research this. What's actually the more of the differences between these kind of papers and how this can help the prediction. For us, it actually did help in the competition to include all the papers. So we did a bit of exploration around this, and we actually ended up having better results using all the papers. It would also, as I said, be very useful to mark these. For instance, like the difference between the camera-ready versions and accepted papers. Like having that also marked down, you could also take that into account when you do the prediction. Like, what is the rate of like new authors coming up? What is the like new affiliations that tend to do that for whatever reason? Of course, you could improve your results even more, right? The more signals you have. You want to add? No.
So on a related note, Yujie, you had looked at some of the related conferences around, and one of the things that I didn't quite follow whether or not you had looked at is whether or not you were looking at any trend analysis for related topical conferences that may be drawing publications away from SIG-IR, for example. Were you looking at them just to sort of look at the overall distribution of institutions across a set of conferences around a topic, or were you also looking at whether or not some conferences might actually have a pull and would then influence this year's SIG-IR, this year's KDD?
So sorry, I don't quite understand your question.
So if you think about this as a sort of a time series graph where you talked a little bit about papers being accepted or not accepted from one conference and then applied for submitted to another conference.
Yeah.
But did you look at all at whether or not there was trends of institutional affiliations being reduced in one conference because they were being attracted to other conferences?
I didn't check this, but I think the actual condition is that it is somehow very random. Maybe one conference it published many papers 3 years ago, but not many conferences 2 years ago. But again, many papers in 2 years ago. So and in other conferences, similar conferences, the situation is the same. So we actually we add the similar conferences just to want to add more information. So I think if we only consider one conference, if it is very possible that they do not publish many papers in recent 3 years because we only use the last 3 years. But I think after adding similar conference features, then the information we use in the feature set is more stable.
So all your works are great and very fantastic. So my question is, if your works were to be deployed into a real production, what else do you need to improve to be able to use your works into a real production? Would there be anything that prevents from doing this? for your work?
Actually, I don't think this specific task is can be can make it actually an application. I think it's maybe it's more interesting to do some kind of application like to rank the institutions, but not predicting how many papers they will be accepted. So maybe it's interesting to give a rank of institutions in machine learning. So I think there might be some differences to with how to rank the institutions of their research impact, or to rank the institutions based on how many papers they were published in this year.
Yeah, I have a quick answer. I think the stuff that we tried to do in each of the phase was to kind of have a more smooth prediction if across the years, and I think this can be improved if somebody wants to take this into production, because there's a bit of depending on the conference, you have a bit of erratic kind of prediction score, NDCG for instance, for each of the conferences, and you have to explain that somehow. You cannot go like this like every year. It has to be like better, I would say. But I agree with you. I think that it's not the right problem to kind of take it into production like it is now. It has to be a bit rephrased in a new perspective to be more useful, I think.
Yeah, I think I feel the same way. We have computed the NDG score for just 3 or 8 conferences. Like, it's a very small sample to come out with to go for production. I think you need a bigger sample. You have to test it out on more number of conferences, and if we are able to create a model which is stable across all conferences, then we can go for production. So that's what I believe.
Right. I have one more question. I have heard like a stableness for multiple times, right? Because stableness is very important to be generalized, right? So for the results. So what kind of features finally lead to this stableness? So far I've heard like using more data definitely can help stableness, like the first 2 things or user-related conferences, right? Because once you have more data, so we can see you have better generation. So what else? What do you think? And by the way, how do you measure stableness?
Yeah, that's a good question. I would say what helped us a lot was features based on sort of the mean number of papers or relevance of past years, and also the sort of the trendiness of things related to those affiliations in the last year. It could be other features sort of that captured this trendiness in the that captured this affiliation's trendiness, or it could be something better related to the authors. So definitely, I mean, you could experiment with that and improve things. What I wasn't like so happy about was that, is like you say, it's hard to measure this to get like a stable. I would have liked that to say, okay, of course, more years and having more data and historical trends will be better, but we couldn't like achieve that. So I don't really know.
Just curious to know that once you read the problem statement and it was looking like a graph structure, what comes to your mind, the first thought, how will I be solving this problem? Whether it should be a page rank applied on a graph, or should I be using the supervised learning or something like that?
I think the first things that we tried was actually to look a bit at the data and see if simple things actually work. Like, we saw the mean stuff immediately, and we thought, okay, it's going to be centered around that. So I mean, it doesn't have to be very, very complicated once you have that kind of pattern that you can notice. And then seeing how we did in the first phase, we thought, definitely, we're just going to stick to something around this. There's no point in trying complicated stuff. I guess it's also a matter of what things you know maybe better and what things. I mean, you could formulate this problem as a lot of things. You could be like network or prediction or like joint probabilities, as you guys did, and all those kind of like Bayesian networks to see like what influences what. And unsupervised, like I saw some teams that used probably deep learning. They had that in the name anyway. So it must, yeah. I mean, why else would you use that? So I don't know. I guess it's also a matter of usually trying simple stuff out and then simple first and then improving gradually. I don't know. Yeah.
Hi. So we have actually tried a bit of unsupervised learning when we tried to calculate those paper scores inspired by the Wisdom conference, by the paper that won the Wisdom conference this year. And by calculating those paper scores, we used the citation graph. But this basically provides a score for the paper overall. It cannot catch a trend because it calculates like one simple score. So that's why I believe it did not help in the prediction of the next year's rankings, because that score is sort of fixed. Another thing is when you use the citation graph, usually citation happens after 1 year or 2 years or 3 years. It has very big variance in the number of years it influences ahead, right? So that's why it cannot really use previous year's data to predict next year's, rank. So, yeah.
Yeah, in fact, that was one of the nuances of the Wisdom Cup paper ranking challenge that we did, which is that we asked teams to rank papers that were not old enough to actually have citations. And so there's only a limited amount of reliance that you can make on pure citation counts in order to do well in that competition. So, good. Yes, one more question, then I think we'll probably take a quick coffee break and wrap up after that.
So, I guess that all of you have tried multiple approaches before submitting your final solutions. So I just want to ask about, did you verify that, how did you verify that the solution that you are submitting that is performing better than other solutions that you have tried? Because I don't think that there was any way by which you can validate your approach.
So for the first conference, we thought we'll go with the leaderboard score, but so from the phase 2 onwards, we had we built the model using the 2014 data, and then we used the 2015 data as our validation set to know how we stand, like which models to choose, which models, like which are the models to choose. So that was the one thing, and beyond that, like the cross validation scores which we try to compute, if the cross validation scores are stable, or same, then we went with the model. These are the two things which we saw.
Yeah, I think in the first phase we tried the very simple probability-based model. We just wanted to see how it works and how we do in the first phase compared to the other teams. We actually validated it using like past year's data and then predicting each of the years, like 2013, 14, 15, and we saw that it gets better. At least we kind of had an intuition that it's going to be like SIG-IR, for instance, chosen in the first one, because the others had dates also which were very far into the future compared to this one. So we saw this pattern in 2 out of 3 conferences in the first phase. So we said, let's see how it goes. Basically, we didn't have any other model because we actually started the competition very late. We didn't have enough time, and we just went with this. Just some exploration, and then just a simple model because the phase was 20% of the final score. So we just wanted to have a baseline and actually to know that we implemented even the scoring correctly ourselves. And then we tried, for instance, we basically validated it and made sure that it wasn't overfitting using cross-validation in the second phase, and also like predicting each of the years, like 2012, 13, 14, and 15, and then just making the final submission from this for the 16 for this year. In the final phase, we compared against the baseline, which we knew was good, because we also tried it on KDD, the crawled kind of list from 2016, and we saw that it was actually above the first place if we had used that. So we said, okay, this is going good. This, like, our final model was actually better than the baseline, so we'll just go with this. This is how we tested it.
As I said in the presentation, in the experiments, we train our model as we predict the rank in 2014, and then we test the model by predict the rank in 2015, and both 2 parts we know the ground truth, and finally we use both of these training data and test data to train the model again to predict the rank in 2016, and we do not change our model according to the results of phase 1 or phase 2, because I think the evaluation is only one conference in each phase, and in the experiments we found that the experiment results is varies in different conferences. There are not necessarily if our model has ranked not very high in phase 2 or phase 1, but it does not mean our model is not good. So we just try to do if we found something that is interesting and we think that may help with the prediction, then we do it. And if the performance maybe it does not increase a lot, but we still think that is good because maybe it can maybe it can work well. Yeah.
I think on that note, we should take a coffee break. Please join me in congratulating our top 3 teams one last time here.